Okay, Chapter 4, Day 3. These two topics, standard deviation and variance, and I know I've said this quite a few times, but we do talk about standard deviation and variance throughout the entire year. The conversation that you've been having about histograms and dot plots, etc. Standard deviation is the last piece of that puzzle. So please make sure that you understand this, and it comes back in Chapter 6. We spend quite a bit of time on it, and really in many of the rest of the chapters and all the way through the end of the year, we're still talking about standard deviation. Okay, so hopefully you watched the video on standard deviation about against all odds. If you have not watched it yet, it might be a good idea to pause this video and go back and watch that, excuse me, so you have a practical application of what standard deviation is. And when you hear the word standard deviation, I want you to think about how far away from the mean the data is. That's what standard deviation is. So again, trying to have you pay attention to words that you already know. If somebody deviates, or it's a deviation, if somebody deviates from society, they're different than the rest of the norm. Okay, they're different than what is actually happening. And that's kind of what standard deviation is. Okay, we're looking at how far away from the mean is each data value. So it's talking about spread, and range is just the highest value minus the lowest value, but standard deviation is looking at, given the mean of the data, based on the mean, how far away from the mean are all of the data. That's what we're looking at. So it's the distance that a data value is from the mean. Okay, so the other piece, when you start looking at the formula, which looks kind of scary, although it is not, you're squaring the differences between the mean and each data point. Okay, because what we're doing is we have to add them all together, and there are some on either side of the mean. Therefore, when we add them all together, they will cancel each other out. And we want to make sure that we have a positive value. So that's why we square all of those differences. So here's the scary formula. And actually, when it's squared, it's the variance. So the only difference between the variance and the standard deviation is the variance is squared, and when you take the square root of this, we have the standard deviation. So that's really important to remember, that the variance is s squared because it's the standard deviation squared. So we sum. Remember, this big sigma is to add. So you've added all of the differences between every data point and the mean. You square it and you divide it by n minus 1. We will talk more about why it's n minus 1 later. For now, just memorize that that's part of the formula. You will be asked to find standard deviation by hand and also by using the calculator. And make sure in your calculator that you're looking for the s. Okay, so variance, remember that it is squared units, and I think that's it for right now with variance. Okay, so now we calculate the standard deviation. So all we do is we take the square root of the variance, and now we have the standard deviation. So that's how we get this. You add up all the differences between the data point and the mean, square it, divide it by n minus 1. N, I should say, is the number of data points. Number of pieces of data. Okay, so it's just the square root of the variance. Okay, the standard deviation is in the same units. Once we square everything with variance, we really don't have units anymore because it doesn't make sense that all the units are now squared. So that's another thing to keep in mind, is that standard deviation, it's going to be the same units because we've taken the square root of the variance. Okay, so when we're talking about variation, and I put this in purple so it was very obvious that I want you to have this in your notes. When the data values are tightly clustered together, the IQR, the difference between the third quartile and the first quartile, and also the standard deviation will be very small. So if I looked at that on a graph, well, not very straight, but if I looked at a graph and I said that the data is very much centered right around here and it's clustered together, I will have a smaller variation. The standard deviation will be smaller. If the data is spread out like this, then the standard deviation will be larger because the differences between here and all the way to here are greater. This is different than this. I tried to make this more clustered. Maybe this would be a better difference between these two. Okay, so here it's very clustered, small standard deviation, small variance. The IQR is very small. Here it's very spread out. The IQR is large and the standard deviation is large as well. So now is a summary actually of chapter 4. So when talking about quantitative variables, you want to make sure that you're drawing a histogram or a stem and leaf display. I'm going to go through these notes pretty quickly. You should have all of this. I don't know how much of this you will actually need to write down. If you don't have it obvious in your notes that quantitative variables are histograms and stem and leaf plots, make sure that you have that down. So here's a list of what you're going to talk about. You're always going to be reporting the shape with the center and the spread. So these are 3 words that I continue saying. Make sure you have that in your notes. If it's skewed, you're talking about the median and the IQR because the mean is no longer a good indication of where the center is. Okay, so skewed, you're talking about the median and the IQR. If it's symmetric, then you're talking about the mean and the standard deviation. And depending on the data, you might want to talk about the median. You might want to talk about the relationship between the mean and the median, and also what is happening with this 50% of data between the lower quarter and the upper quarter. So what are some unusual features that you notice? Here's another thing to talk about. So if there are multiple modes, maybe you want to understand why. Maybe there's a question that you have based on the story that you're trying to tell. Maybe there's a reason to split into 2 groups and you want to split the modes. Maybe you want to split the data. It depends. Okay, so if it's multiple modes, you want to talk about why that is and maybe change the picture based on trying to get more information. If there are clear outliers and you are reporting the mean and the standard deviation, then you want to talk about that. Report them with the outliers present and with them removed, and maybe it's going to be obvious as to what that outlier is. Think about the data that we looked at on September 11th with the flights being canceled. Well, that outlier was something significant. If we removed it, it would be that much more obvious that there was something going on that caused that to be so far out there. Okay. So again, in your notes, the median and the interquartile range are not affected by outliers. They are resistant, okay, because it's not going to matter where they are. Okay, so what can go wrong? Please, please, please make sure that if it's a categorical variable, you're using bar charts or pie charts. Don't make a histogram out of it. If it's a bar chart, you can't look at shape, center, and spread, because we don't have numbers along here. We can't tell what's happening with there is no shape, center, and spread. It's just the categories that are given to you. Don't use bars at every single display. Make sure you're saving them for histograms and bar charts. So one of these is a better representation than the other. So what do you think? Which one is the better choice? One is displayed well and one is not. So which one do you think? I think this one is a better display of how many bald eagles there are. We want to know, why is there a change per week? This one is harder to tell. There were 0 for 8 weeks and 2. I mean, we're comparing this doesn't tell you very much because it's all the same height. Whereas this is saying, well, wait, why in week 9 were there so many more bald eagles shown? You want to make sure that you're picking a bin width that makes sense with the data. Changing the bin width changes the appearance. You had that example in the first worksheet that I gave you where with the states, and you redid that histogram many times and showed some of that was better and some of it wasn't. So you're making sure, well, what makes sense with the bin width, okay? And again, just the story you're trying to tell. These are very, very skinny. This is really hard to read. This is much easier to tell. There's a lot on here. Don't forget to do a reality check. Use a calculator, but you are smarter than the calculator. The calculator is just doing some of the work for you. Make sure that it makes sense. That's really important. Think back to the forgetting to read the bottom of the chart that we looked at, the histogram that we looked at, where the people over 65 was in thousands, and many forgot to write that down. That makes a big difference. So make sure you're paying attention to the data and what's there. Don't forget to sort the values before finding the median and the percentiles. Don't worry about small differences when you're using different methods. Don't compute numerical summaries of categorical variables. Really, 1 or 2 decimal places is fine. It depends on the data that you're looking at. So you don't need 18 decimal places. 1 or 2 is fine. Always round at the end. We haven't talked about this very much, but when you're doing a lot of calculations, you want to make sure you're rounding at the very end, because if you round as you go, it will change your results. Multiple modes, maybe you have to split the data. Outliers are never a bad thing. Find out why they might exist. So here's a quick summary of what we've learned. So you've learned to make a picture of quantitative data. You can use a histogram, a stem and leaf plot, or a dot plot. And you've learned to calculate all these different measures. Measures of center, the median and the mean, the range, the IQR, and the standard deviation, and what happens when it's skewed. Now, in this summary, there hasn't been negative skewed or positively skewed. So make sure that you have clear notes with that. And that will come back when we talk about box plots in the next chapter. Okay. So we've learned to think about the type of variable that you're summarizing. All the methods of this chapter assume the data are quantitative. So if the data is quantitative, you could use all of these things. Okay, and that is it with this last section of chapter 4.